In today's video, we're going to discuss uh, the project scheduling technique, which is an operations research technique used for scheduling projects so that projects which have been undertaken are completed within the stipulated time. There are two techniques which are covered under project scheduling technique. One is the CPM and the other one is called the Pert. So the CPM stands for critical path method, and the critical path method is defined as a technique where you identify tasks that are necessary for a project completion and determine scheduling flexibilities. A critical path in project management is the longest sequence of activities that must be finished on time in order for the entire project to be completed. Any delays in the critical tasks will delay the rest of the project. Critical path methods revolves around discovering the most important tasks in the project timelines, identifying task dependencies, and calculating task durations. CPM was developed in the late 1950s as a method to resolve the issue of increasing costs due to inefficient scheduling and project delays. Since then, CPM has become popular for planning, project prioritizing tasks. It helps you break down complex projects into individual tasks and gain a better understanding of the project flexibilities. Now, projects are undertaken on a regular basis. It can be anything. It can be a project, it could be a personal project. It could be developing a product. It could be like construction of a building. It could be construction of a dam. They all have a sequence of events, and you want to complete the project within the stipulated time. And it also gives you a chance to think how much time it's going to take to complete the project. So the project scheduling becomes an integral part, a sine qua non of project management. So every project, at the end of the project report, they'll ask you something, what is called as a project timelines. And the project timelines are based on CPM or PERT, and eventually the outcome of these two would be a Gantt chart, all of which we're going to discuss in this lecture. Now, when we do project scheduling, now you should not confuse project scheduling with project management. Project management is about a complete project. The sequence in which the project scheduling helps you to achieve the project in a very efficient way without any delays. So project scheduling starts with, of course, project schedule management itself. Then an important thing in project scheduling is you should find out what are the important activities. So you should break down a project into the very important activities. Then you should know which activity is related to what. So, because in any project, some activities are related and some are not. So that dependencies of activities should be understood. Then once you've identified the activities, identified the dependencies, then you sequence it in a way that the project is completed in a particular sequence, which you can then monitor. Then you need to estimate the resources because no project can be undertaken without resources. Then the time that each activity that you've identified is going to take. And then you develop a project schedule. And once that project schedule is developed, the model is done, then you have to monitor it using a Gantt chart. So here is an example of a project where we want to develop a product which gives price forecasts to the consumer. Project can be a product, it can be a service, it can be virtually anything. It can be a project, it can be a product, a service, or whatever. So we are going to discuss. So the first thing, like we correctly mentioned, is that you have to identify which are the important milestones. And a word of caution here is when you're thinking through a project, all important activities which are going to take time and are of significance have to be identified and put down as a milestone. So leaving out an important milestone can affect the completion of the project and the efficiency with which the project is undertaken. So here is an example. So the first step is to prepare the project proposal. And then once you get that project idea, then you brainstorm among your friends how it should be structured, what are the various dimensions that's going to cover. Then once you've got a clear idea, you have an idea, you get the ideas of the others, Then you prepare a blueprint of the project. What is that project going to do? What is it going to achieve? And how can I break it down into different parts? Then once you've got the project fairly well within your control and kind of finalized, then you can draw up a financial plan. Because no project can be undertaken without a financial plan. So you draw up a financial plan, then you discuss the technical features of the project. Now you talk to experts, and then you get further elaboration, further clarity on the technical aspects of the project, and that's another landscape. Then once you've got these technical details right, and you know what the product is going to be, then you have to then think about what's the data that I'm going to use to roll out this product. So I source the data, at least talk to people about the data, then source it. Then I develop my forecasting models. The next step is activity G, which I call G, is developing the models. And once I've got a clarity on what my product is going to look like and what are its, I'm in a position to convince the financiers. So then I make a pitch. I mean, I go to a financer, investor, and then present my project to him, and along with the financials, because I have to talk about the financials. And then I try to attract him, and I try to attract his attention and his interest in financing the project. Okay. And then once I get a kind of clarity that this project is bankable, there are people who are prepared to finance it, then I develop the model itself. I develop a test version of the model. And then once I develop a test version of the model, then I test it, whether it's working in the laboratory or in a very closed circle. And then I'll develop the app itself, and then I call it a beta version of the app, which will have bugs. And then once the beta version is ready, then I can go and talk to the financer and get his buy-in to the project. I mean, I must get a commitment from him that he's prepared to take the project forward. So I have to talk to 2, 3 people. If one person is not interested, I have to go to another person. And finally, tie up the finances, and I have a ballpark figure on how much it's going to cost, and that has to be tied up. So that becomes the next important milestone. And once the finance is tied up, then I test the features of the model, because when you talk to a financer, he will also give you his inputs as to what he wants the product to look like. And then you test the features of the model. And then once it's developed, you test it on the field. You give it to some people to use it, get their feedback from them. So you've developed a prototype for the model, and then you give it to the market, and then you get back the feedback. And based on the feedback, you will revise the model once again. And once that model has been revised, it will be implemented, either as a web application or a mobile application, whatever it may be. Then for each activity, I should know the precedence, which is nothing but the dependencies. I know activity B has to follow activity A. So I give the precedence here. Activity C has to follow B. Activity D has also to follow B. And like this, I find out the dependencies. I also decide how much is the time each activity is going to take, the time that each activity is going to take. That's going to be my job. So once this milestones have been decided, the sequence has been divided, the time has been divided, I next proceed to draw a network diagram. I draw a network diagram. So a network diagram will have nodes and arrows. So from one node to another, you get the activities. So arrow actually represents the activities. And the length of the arrow has no significance. But the only thing I need an arrow. So the first arrow relates to activity A, and I write the time period also. So this is how conventionally it's done. So activity A will move from node 1 to 2. So you don't have to worry. This has no significance. It's just a sequence of numbers. So activity A, which relates to preparing the project, preparing a proposal, is the first activity, and it will take about 3 weeks. Then we go to the second activity, and the second activity is B. And the B activity is brainstorming. Then we get activity C, which has a duration of 3 years. So we have to write it like this. We have to write the activity name, or the abbreviated version of the activity, and the time that is going to take. Then we go to activity E. So when I draw this activity E like this, it implies that E follows B, or sometimes even A. So after B is completed, only E can be taken. After B is completed, only C can be taken. But C and B are not there is no dependency between C and E. So you just sequentially number the nodes. So there's not much of a significance. So now we got E. Now we move to F. F is, sorry, so F has got a duration of 5 weeks. And then we get G. Now G is, now when I draw it like this, it means that G is preceded, like you can see the arrow, the heads of the arrow, they're leading it. So it means that G is preceded by E and F. You can see it. Okay, so G will be preceded by E and F. And then you put the next load. So I put the number, it's going to take 6 months. Then I move to node 6. Then I get the node, I mean, that's sequentially wrong. Then there is an activity D, which is preceded by C only. So the arrow's direction is very important. This network diagram is the most important thing that you have to do in project scheduling. All the other things you can automate, but this you cannot. So you need to do it manually. Then we get activity I, which is duration 3. So it moves to the next node, that should be in 7. So then 5, that's 7 for that. H should come before I, so the sequence is wrong. So H has come and then you get a node. Then H, I has come here, then K has come. Now from this I can make out that K is preceded by H. Right. Then when you see this, this is very important. This is called a dummy node. Now this strictly means that K is preceded by H, F and G. F and G. No, maybe, sorry, D, not F and G because G is not there. It is preceded. Now when I draw a dummy node like this, it means that K is preceded by G and D. G and D. H is also there. Yeah. K is preceded by H, G, and D. Sorry, I didn't. So H, G, and D. This is very important. So K is preceded by H. Since G, I cannot draw a parallel node. I cannot draw a parallel node like this. So G, anyway, this has to come here because it precedes I. So from this is a dummy node. It means that this is preceded by both H and D. H and D. So this is very important. How you draw the network diagram is very, very important. Then we get activity J. This is nodes are just numbered in sequence. And also you should remember that when you draw a node, it will always be from a lower node number to a higher node number. So it's always from 6 to 7. It can't be the other way around. And it's not necessary also. But you must take care that it doesn't move from a lower node to a higher node. Okay, so that's the L. The L we have named what this is. These are. Then L precedes M, and M precedes N precedes O, and finally we end with P. So you can see that this is how you draw a network diagram. So you should give the dependencies. Now looking at K, now you can make it L is preceded by K and L because you can see it by the arrow. L is preceded by K and J. Okay, so this network diagram has to be drawn along with the activity and the duration of each activity. Wherever necessary, you have to draw a dummy node. Where it's not necessary, you need not draw. But this is the first step that you should, and the most important step in project scheduling. Then, after the network is done, then we find out how much time it is going to take from reach from here to here, and how much time it's going to take to go back from here back to this. So when you move forward, you call it the forward pass. So we start like this. We'll start like this. We'll start at time 0. And this will take, so the earliest start. So when we do the forward pass, we get the earliest start and earliest completion of a project activity. So if I start this project on time 0, the project will end in time 3, week 3. So since this precedes B, then this project can start only after this ends. So this will start in 3 and it will end in 4 because there is only 1 month. So I'm going to show you that. Similarly, I'll find out 4. Now this is going to be a precedent. So this will start at 4 and end at 6, the duration is 6. And this will start at 4 and end at 7. So that's what I'm going to show you. That's called the forward pass. So the forward pass gives me the earliest start and earliest finish. I've denoted it in red. So it starts at 0. So assuming we just give an arbitrary starting point, whichever that might start at 0. The duration of this project, it will earliest finish will be in 3 months. Then this will start at 3 and it will end at 4. Then C will start at 4 and it'll end at 7 because it takes 3. So 4 plus 3, 7. E will start at 4, it'll end at 6 because if it starts after this is over, it'll start, takes 2 weeks and it'll end at 6th week. Then this activity will start after this is over, so it will start at 7, end at 8. Now we go here. This will also start at 7 and it'll end at 7 plus 5, 12. It'll end at 12. This is how the forward pass is done. So you have to go in the same sequence. Now when we come here, there are 2 precedents. Does it start at 6 or does it start at 12? So obviously when you're doing the forward pass, if there are 2 candidates to be considered, choose the longer. So that's why he puts 12 over here. Duration of the project is 5, so earlier start is 12, ends at 17. Then this one. Okay, this one also has a 2. So 6 and 12, so it starts at 12, and there is 6 months duration, ends at 18. Okay. This we have already done. Then we come here. So you have 2 candidates. So you have 18 and 8. So the longer of the 2, this you have to be very careful attention. The longer of the 2, 18 plus 3, 21. Then here. Now here, this is tricky. Look, this you have to be very careful. Look, now these 2 are preceding this. Along with, look, this has got H, D, and G as precedence. So 8, 18, and 17, the longest of the 3, it will start at 18. So this you have to pay a lot of attention. Otherwise, you will make mistakes. 18 plus 6, 24. Similarly, this also. This, of course, there's only one precedence. So it will start at 21, end at 25. Then here, of course, there's a tie. It will have to consider one of these. It will take the longer. So 25 plus 3, 28. And thereafter, this will start at 28 plus 4, 32. 32 plus 4, 36. 36, once this is over, this starts 36, it takes 2 months, it ends at 38, and this starts at 38 and ends at 41. So now we know that this project is going to complete in 41 weeks. So whatever project you have considered here will end in 41 weeks. So now I need to find out which are the activities are very critical. Which are these critical activities in this? All are not necessarily critical. So for that, now I've done the forward pass. Now I'll do the backward pass, which I'll move in exactly opposite direction. I'll remove these and I'll use only the backward. So I'll start with 41. 41 minus 3 will give me 38. This will end at 38. 38 minus 2, 36. 36 minus 4 is 32. Then so the backward pass I'll write down. Forward pass I write at the top of the arrow. Backward pass I'll write at the bottom of the arrow. So now we're going to move to backward pass. Backward pass gives me the latest start and the latest completion. Gives me the latest start of a project and the latest completion of the project. And I start with 41 wherever I've ended and it goes backward. So 41 minus 3, 38. So now 38 comes here. 38 minus 2, 36. So 36, 38. Then this 36 will go here. 36 minus 4, 32. Then 32 minus 4, 28. Now you have a problem. Now, of course, this 25 will be both for this and this. You can just see. So this 25 minus 4, and here also will be 25 minus 6, 19. 25 minus 6, 19. Then we go here. Yeah, now this is very tricky. We will pay a lot of attention to this. Now this is preceded by this. This precedes this, right? This precedes this, and this. Okay, so this is preceded by this and this. So this is 18. Can you see that? This is preceded by this and this because of the dummy. This and this. So here you have an 18. Here you have a 19. So when you're doing a backward pass, you choose the smaller of the two. When you're doing the forward pass, you choose the larger of the two. So between this, we'll take 18. Okay, 18 minus 6, 12. So please pay careful attention to that. Look, now this precedes both this and this. So I need to consider both these before I can evaluate. So here I got 18, and here I get 19. So I choose the shorter one, 18 minus 2. So remember that whenever there's a tie, you only have a problem. Here there's no problem because there's only one precedent, so it ends at 14. 14 minus, 16 goes here. So this is so this is 19. 19 minus 6 is 13. 13. 13. 13. Right? Now 13. Now. So when you're considering this is a precedent, this is also a precedent. So I'll take 19 and 18, and I'll take the lower of the two. I'll take 18 minus 1, 17. Right? Then I'll have to consider this. Now this is preceded by this. Right? So E and F precedes G. So I have to consider G. G, there is 12 and 18. So I'll take 12 minus 5, 7. Now this is also preceded by this. So here also I'll take the same 12 and minus 2 will make it 10. Here minus 5 makes it 7. So this, yeah, this is tricky. Now this is preceded by this. This is preceded by this and this. So the shorter of the two is 7. 7 minus 3 is 4. Then this is preceding this. Okay, there are 2 here. So this is 10 and this is 4. So you choose the lower. So it's lower of the two. So you choose 4. 4 minus 1. 4 minus 1. 3. Then 3 and 0. So now you got the backward pass, which gives you the latest start and latest completion. Forward pass we did earlier. Now we'll put them all together into one graph. We'll make one overlay the other. So I put them together, integrated both the forward pass and the backward pass. I've got the entire figure, and now I'm going to decide the critical path. The critical path is very easy. Now we know, take this as an example. This is earliest start, earliest completion. Latest start, latest completion. You choose the earliest completion and latest completion. That is this 3 and 3. And if they are the same, if the earliest completion and latest completion are the same, then this becomes one critical activity. Come here, 4 and 4, this is also a critical activity. Come here, 7 and 7, this is a critical activity. Come here, you get 6 and 12. This is not a critical activity. E is not a critical activity. Then come here, T has got 8 and 19. This is not a critical activity. But when I come here, you must take the red and the green. This is 12 and 12, critical activity. This is 18 and 18, critical activity. So on and so forth. So we will find out the critical activities depending on the similarity, coincidence of the earliest completion and latest completion. Now we must check this activity wise. First, you see this is going to become dark. 3 and 1 activity. Next, this is also red. So please note this correctly. So this is not, this is. That becomes a critical activity. D is not, F is. G is critical activity because these two are the same. Then it goes to I, it goes to J by the same rule. 25, 25, 28, 28, 32, 32, 36, 36. Must be careful because it's a little cluttered. You may 36, 36, 38, 38, and 41, 40. Just to see it once more. That's my critical activity in a different color. So this is what I'm trying to find out. Which are the activities which I cannot afford to delay even for a day? Other activities I can take time. I can take time because This is called the free float. Earliest completion minus latest completion is called the free float. 0, 0, 0, 0. Sorry, no, that one, yeah. 0, 0, 0. So earliest completion minus latest completion. Latest completion minus earliest completion. If it is 0, then that is critical path. So that's another way of defining the same thing. So now we found out the critical path. The critical path is one technique for project evaluation. There's another technique called project evaluation review technique, which is also referred to as Pert. Very similar, except for this, what I'm going to show you. Pert, Program Evaluation and Review Technique, Pert, is a technique adopted by organizations to analyze and represent the activities in a project and to illustrate the flow of events in a project. Pert is a method to evaluate and estimate the time required to complete a task within deadlines and to stick to those deadlines. You should follow the Pert. Pert serves as a management tool to analyze, define, and integrate events. Pert also illustrates the activities and interdependencies in a project, just like CPM. And the main goal of Pert is to reduce the cost and time needed to complete the project. Okay, so this is the basic thing. So the procedure is the same milestones, the same durations, the same sequence. The only thing is for each act, like this is the thing for a Pert. So you had the most likely time. You said you assume that these don't change. But strictly in reality, this is not much in your control. It could take, so you give, when you do Pert, you give to it, this is called the most likely. You give an optimistic time and a pessimistic time, which is written as A and B. So this is most likely is written as M, most optimistic is A, and most pessimistic is B. For example, if you're very optimistic about writing this proposal, probably you can write it in 2 weeks. If you're pessimistic, so you need to brainstorm on this. All this remains the same. And we've done the same problem as a Pert. So here we introduce these two columns. So this first column, we call it most likely. And then I say, if I'm optimistic, I can finish it in 2 weeks. If I'm pessimistic, I can take. This has to be very objective. Now, brainstorming, I can finish it in half a week. And 3 days is enough. I don't have need 1 week. Or I can take 2 weeks. So for each activity by activity, you must give us the most optimistic and the most pessimistic times. And then we do it just like a Pert. In a Pert, we use these values. In CPM, we use these values. In Pert, what we do is we calculate what is called as a mean time. Instead of using this, we calculate mean time, which takes into consideration this. And we also calculate the mean variance. The formula for mean time is 4m plus A plus B. 4m plus A plus B divided by 6. Divided by the whole thing divided by 6. This whole thing is a weighted average. So we give more weightage. So this whole thing should be divided by 6. That's the mean. That's how the mean time is calculated. Just a slight, one additional step is there when you move from CPM to Pert. And the variance is calculated as A minus B, that is the most optimistic time minus pessimistic time, the whole squared, divided by 6. So the mean and the variance are calculated additionally in this fashion. So the mean would be 4 into 3, 12, 12 plus 2, 14, 14 plus 5, 19, 19 divided by 6 is 3.17. So this will be 4, 4.5, 4 into 1, 4, plus 4.5, plus 6.5, divided by 6 is 1.08, 6.5 divided by 6. So for each activity, you'll calculate the mean using this formula. And for each activity, you'll calculate the variance also using this formula. So this formula will be 2 minus 5 the whole squared divided by 6 gives me 1.5. 0.5 minus 2 the whole squared divided by 6 will give me 0.3. So for each of these activities, I calculate the mean time and the variance of time. And I use this to do the forward pass and the backward pass. Everything else is the same. You then use these values and do a forward pass and use these values and do a backward pass. Sorry, use these values and do a forward pass. Use the same values and do a backward pass. So there, if you remember, we got a figure like 38 weeks. It's going to take 38 weeks. Let us see how, because the mean values have changed. What was 3 has now become 3.17. What was 1 became 1.08. What was 3 has become 2.83. What is 1 has become 1.25. So we have a new set of numbers, which we then use to do the forward pass in the same way like we did in a Pert. But since these are fractions, you have to be a little careful. Okay. So this is nothing but the network diagram, but with revised values of project durations, of revised values for project durations. Okay, so we're just doing the same thing for you to understand. Then we calculate the earliest start, earliest finish. So it will be 0 and 3.17. You get the earliest start and earliest finish. Or earliest start and earliest completion. You use it both ways. 3.17, and this time is added and the earliest completion. So now this will start at 3.17 and end at 4.25, which is nothing but 3.17 plus 1.08. So this precedence has to be kept in mind. It has to be kept in mind. The precedence should be kept in mind. So these are all written on top of the arrow. They're all written on top of the arrow. So this is how we get the project. It's the same way, so I'm not repeating. So this project will finish in 41.42 weeks. According to that, we thought I think it will finish in 38 weeks. Now, because we took the variations in the durations and the uncertainty into consideration, duration is increased to 41.42. Now we finish the forward pass. We'll now do the backward pass. So we start with 38.42. We start with this 41.42 and subtract 3, you get 38.42. Same way we do. So we get the latest start and latest completion. We just write it in the same way as we did earlier. I'm not elaborating because you have already explained it. So you got the latest. You got this. So you'll come back. It should come back to 0 and 3. Now I'll superimpose the backward pass and the forward pass together. This is the duration. Now superimpose both the forward pass and backward pass together and use the same principle. Now, this is a critical path. This is a critical path. This is a critical path. This is not a critical path. We'll start at 6 and end at 4. Okay? And then you'll now see me preparing the critical path the same way. That's the first one. You have to just pay attention to this 4.2 and 4.2. And then you look at this. It becomes 7.08 and 7.08. Then we go up. Then you get 12.25 and 12.25. We come down. Then you get another 18.42, 18.42. Then it goes down. It comes to 21.42, 21.42. Then you go that way because there's 25.58, 25.58, 28. You can see that. So we've identified the critical path using Pert. But in Pert, there is one. You would have noticed I've already also calculated variance. Now, how am I going to use the variance? I know the project duration. It's going to take 41.42 days. So Pert is probabilistic. CPM is deterministic, meaning you know the values for certain. Whereas in Pert, you assume that you don't know the values, and therefore you introduce an element of variance. So now, we'll get the mean values, the same thing. We calculated, the formula was there. This is 4m plus a plus b divided by 6. And this is a minus b the whole square divided by 6. And then what you do in the additional step that you do in Pert is after you got the critical path. Now we got the critical path. Critical path is A, B, C, F, G, I, J, L, M, N, O, P. Because you can't see the whole thing. M, N, O, P. Right? So add from the standard deviation, from the variance, you calculate the standard deviation by taking the square root. I'll show you. So you take the square root. So I must add it along the critical path. So what I've done is I've accumulated it. 1.5. 1.5 plus 0.38 is 1.88. 1.88 plus 1.5 is 3.38. These are all critical, these are not, so I don't add. Then this is another critical activity. F is a critical activity. So 3.38 plus 4.17 becomes 7.55. This is also critical. So 7.55 plus 4.17 is 11.72. This is not a critical activity. So 11.72 plus 0.67 is 12.39. Down till the bottom, just because I don't think you can see it. Yeah. So the cumulative variance is 19.15. So what you should notice, it's added only along the critical path, not everywhere. Right? Not everywhere. So we get the critical path. Okay. So 14.42 is the time to the total duration. 19.15 is the variance. I take the square root of 19.15, I get the standard deviation 4.38. And then I now calculate what is the probability that I'll complete this project in 50 days, because it's probabilistic. So I have to introduce that element of probability. So I'm assuming a normal distribution. Mean is 41.42, standard deviation is 4.38. And I want to know, given this distribution, what is the probability that I'll complete the work in maybe 50 days? Because when I'm saying probabilistic, I don't say 41.42. I give a probability. Now, the calculation shows that you can complete this project in 48.85 weeks with 95% confidence. Because every project manager wants to, when he quotes a date or a time, because if there's money involved, he wants to be certain. He wants to be certain. And in order to know that, you assume a normal distribution. So just I will take these values and show you how this is done in Excel. Okay, I'll show you how this is done in Excel. Okay, I'll take this. This can be done in Excel, in a simple Excel sheet. You can do this. But I'll show you in a moment. Okay, so we'll just take a blank place. Okay, I'll just show you. These are the data that I have. And I'm going to use, you can use that option in Excel called NORMDIST, N-O-R-M. Sorry, before that, let me just block off one area. And I say this is where I'm going to predict my this thing. So and then here I'll say NORMDIST. NORMDIST. And you'll see it's prompting you, which is the value it is here. What is the mean? It's asking the mean. So I'll just write the mean. Mean is 41.42. Then it's asking you what is the standard deviation. Then I say standard deviation is 4.38. And then it's asking me, do you want a cumulative? Then I say yes. So given the value in a distribution, it gives me the cumulative. Comma. By mistake, I get a full stop. Okay. So here I'll put a value. Suppose I will complete this project in 50 days. The probability will be 0.97. I'm not interested in 97. I'm interested only in 95. So I will say 48.85. 48.85. Then 48.85 or 8 would be a better figure. 48.8 will be 95.39. Maybe 75. Would be 95% confidence. So I can complete this project in 48.75 weeks, almost 49 weeks with 90% confidence. And that is what Pert helps you to determine. So it tells you, it introduces a certain amount of variability into your dates, which is quite realistic. And then tells you with 95, because when you quote a time, when you're quoting for a project and you say, I'm going to complete it in 41 days, then the probability of completing in 41 days will not be very high. You can just say 41.42 will be just 0.45. 41.42. Supposing I say, I'll complete it in 41.42 days. Then the probability drops to 0.5, which is not a good enough probability for when you're quoting for projects and you want to this thing. So this is what the CPM does. Now you've understood both CPM and critical path method and Pert. Okay, you found out how CPM and Pert, they both work in the same way. Now I'll show you. Now this is very important. Now, the network diagram, you have to do it. You have to learn the skills to draw a network diagram because that is very critical because a lot of the information that you need for the project is obtained from there. So now I'll show you how the critical path can be determined using Excel. Using Excel. Using Excel. You could use it for both. Okay. So let me just show you how that's done in Excel. So what you do is let's take the Pert. We got the Pert figures here. Just remember that the average duration calculated in Pert 3.17. What do you notice? 3.17, 1.008. These are the duration of times for all the activities from A to P. This is the time. I'm just copying it from here so that you don't do this thing. Okay. I'll do it again. So take the first one. I'll take this network diagram and identify all these links. So first I'll say A to B to C to D. See the arrows, it should follow. A, B, I'll write A, B, C, D, D, I, J, A, B, C, D, I, J, L, M, N, O, P, N, O, P. This is one. Next one. A, B, C, F, G, G, I, J, K, L, M, N, O, P. Now, next one will be A, B, C, C, F, F, G, and that's the one I think we've discussed. The next one will be A, B, E, E, H, E, oh yeah, E, H, K, L, M, N, O, P. Then there's another one that go like this. A, B, E, there's a link here, no? G, I, J, L, M, N, O, P. And another one can be A, B, C, sorry, E, G, you can go up here, K, L, M, N, O, P, Q, R. So you get many combinations, all have to be evaluated. All have to be evaluated. So basically we're going to evaluate, this is one. So all these have to be evaluated one at a time. So first you must draw the network diagram and then identify all these possibilities. So I've got another one, A, B, E, G, G, K, L, M, N, O, P. Okay, now you've identified all the flows of the network, the flows of the network. Come to your Excel sheet and now identify each one at a time. The first one which I identified is 1. Put a 1 under each. The first one is ABC, ABC, D, D, oh, sorry. So this is not correctly numbered. So this is A, B. The activities are very important. Let's just go and see. So is D, P activities. Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, M, N, O, P. So there are P activities. There are P activities. There are P durations. There are P durations. I mean, the durations. The first A activity took 3.17. We saw that here. A activity took 3.17. B took 1.08. The same thing has to be taken and transposed over here. Okay. Then you trace this. You center it so that it doesn't interfere with our work. Okay, let's just put a center. centered. And now each stream that I've identified, I will have to write it over here. The first one is A, B, C, D, A, B, C, D, D, I, J, J, L, L, M, N, O, P, Q, M, N, O, P. So that's the first one. The second one which I've identified, I'll put once here. Second one I've identified is A, B, C, F, G. A, B, C, F, G, F, G, I, J, L, M, N, O, P, Q, R, S, T. So like this, all the ones that I identified, I put once. And the last one which I didn't identify, one more was there which I didn't. 1, A, B, E, E, G, E, then G, K, K, L, M, N, O, P. Okay. So once this matrix has been prepared and these durations, now this is called the durations. These are the network flows. Network flows. So network flows, I've identified many. Network flow 1. I hope I can drag it and get, so I get network flow 1, 2, 3, 4, 5. So 6 networks we've identified. 6 networks we've identified from here. 1, then 2, 3, 4, 5, 6. So 6 networks we've identified. We want to know which is the critical one of them. So for that, I will do this again. Okay, come here. Okay, come here and say equal to sum product, SUM, sum product, this row, multiplied by this row, which is the durations. This is duration based on Pert. You can do it for CPM also. So only thing is this row has to be fixed. So in order to fix it, what I will do is I will either press F4 or I'll put a dollar here. I'll say D$100 to S$100. S$100. So I got a value like 31.33. I'll copy this down. I'll copy this down. Right? I'll copy this down. And you can just see what I've done. If I go to formulas, and if I say trace precedence, it's multiplying this row with ones with the duration. So I'll get the average duration. So if I get, similarly it does for all, I'll just show you randomly too. This row will multiply this row with the duration times. Okay, so that's how it's done. And it's rather simple. You don't have to do any optimization. The one with the largest, the one with the longest duration is the critical path. So this is my critical path. This is my critical path. And my critical path is ABC, then F, G, I, J, LMNOP. Now this is the critical path. So if you go and see that, figure, you'll get the critical path here. So ABC, FG, IJ, LMNOP. So we've identified the critical path. This is the method. This is how you solve these problems in Excel. Now, once this is done, once this whole thing is done, the last step is the preparation of the Gantt chart. So without the Gantt chart, you will not be able to identify. So now this is clear, I hope. So you know what it tells you. The project doesn't. What it tells you is, if the project is uncertain, you are not going to complete this project in 38 days. You're not going to complete the project in 38 days, 41 days, sorry. You're not going to complete the project in 41 days. But very close. You're going to complete the project in 41.42 days. Okay, 41.42 days. That's not the main thing. And it tells you the probability of completing the project with 95% confidence is 48.85 days or 49 weeks. It will take 49 weeks to complete if you want to be with certainty, because taking the variability also into consideration, you come to. Now I've shown you how to do it in Excel. And finally, we control the project using the Gantt charts. Now, a Gantt chart is the most common tool used by project managers to visualize the timelines and dependencies in a project. You can get a quick estimate of the time required to complete every task that you've already decided, but we're going to put it into a figure where you can visualize it a lot easier. A chart shows all the tasks represented by bars when they are set to start and end, how long each task will last, task dependencies, and where there are any overlaps, it will also tell you. So for that, we prepare what is called as a Gantt chart. And this Gantt chart can be prepared in MS Excel, as I will show you in a minute. Okay. Now we have the project. What is the earliest start? Earliest start, earliest completion. 0, 3, 4 for each activity. So for each activity, we have to find out what is the earliest start and earliest completion. Okay, so you have to make a table like this. You have to make a table like this, and this is the duration. These are the precedence structures, and you calculate the earliest start. What you're doing is you're just taking it down from there. You just copy it down from here. So you can see now, A, B, C. I'll just show you A, B, C. So it is earliest start is 0, 3, and 4. 0, 3, and 4. Earliest start. Okay. So earliest completion also. So we prepare a table like this. We'll prepare a table like this. We'll prepare a table like this and take this out. We'll prepare a table like this, which gives us the earliest start, earliest completion, latest start, latest completion for each activity, which is nothing but this. So earliest start, earliest completion. So 0, 3, 3, 4, 4, 7. 0, 3, 3, 4, 4, 7. Similarly, we'll give the latest start 0, 3, 3, 4, and 4, 7. 0, 3, 3, 4, and 4, 7. Once this is done, we just write it down over there. We just write it down there, and then we calculate the free float. The free float is earliest start minus earliest completion. And the total float is latest completion minus earliest completion. This is called the total float. Right? So we calculate these activities, and we calculate the float, and from the float we get the critical path. So we actually get the critical path like this. So wherever the total float is equal to 0, that's a critical path. That is a critical path. So this, I think, the free float will actually be earliest start minus latest start. Sorry, it's earliest start minus latest. Free float is earliest start minus latest start. So wherever the free float is equal to 0, that is a critical path. So that's how I put the C there. C, 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 C. So you would have seen me. We would have done it here. Okay. D is not a critical activity. So that is how we prepare this chart. We prepare this. Okay, we prepare this total and we find out the preferred. Then what we do is we're now going to prepare the Gantt chart. For the Gantt chart, we need all the activities. So activities A, B, C, D. Then we can do it in two ways. We can do it in two ways. We can take, I'll do it here. I'll just show it to you how it's done. So we'll take these activities. We'll take these activities and we'll take the earliest start value. We'll take these earliest start values. So this you should pay very careful attention to. We take the earliest start values, put it over here, but we must remove the formula because there it'll have a formula. So you come here and you come to paste special values. You need not transpose over here. So you got the earliest start. Then you bring the durations here. So all the information you need here is just the durations. I don't want to take a chance because if there's a formula, then it will distort. So I'll put the value. You need the durations. Okay. You need the activity list. You need the earliest start dates. You will get it from the forward pass. And to this we add the duration. This first project, activity A weeks 3 weeks, activity B takes 1 week. Then to prepare the Gantt chart, you just select this. Then you insert the graph and use this horizontal bar, which is stacked. Right? And here you can give the title. You can say Gantt chart. Or whatever activities that you have. Right? So pay careful attention. Then what I do is I select on this graph and select the blue. Okay. Then I'll go to no line. I'll select the blue and I'll come here. I'll select this. Select this, sorry. Again, once this is prepared, I just select here. And say fill. And I say no fill. I go to this fill and I say no fill. Click it. So this goes. Right? So if I get only this activities. Now then I come here, and because this is in the reverse order, so I want it in the right order. I'll right click, format axis, and here I will get categories in reverse order. So I'll just click it over here and I've got my Gantt chart. Now, from this Gantt chart, I know the activities. This B is not showing. It can, if you make the graph bigger, you'll be able to see it. Make it bigger. You get B. Yeah, all the activities have come. Now, you know this is critical. Once this is over, this has to start. So I'll just make this, sorry, I'll select one at a time. And I'll go here. And I will choose another color. Maybe I will choose a yellow. Okay. This is a critical activity. This is a critical activity. This is a critical activity. Right? This is not, this is not, this is a critical activity. When one starts the others. When one stops, the other should start immediately. Okay. So there you are. So you got all the critical activities. And you know the activities here. And here you'll put one more column and you'll say who's going to do the job, who's going to do this job. And you should only ensure that the same person is not burdened with, no, the same person should not be given these two jobs. Okay, job G and H should not be given to them because they run concurrently. Right. So you can shift, you can go on shifting people. So there should be no overlapping. Like, because it's going to happen in the same. So somebody who's doing A can be given this job B, because once he completes it, he can do. So you can also schedule your manpower accordingly. Okay. The same thing has been shown over here. This is how it's done. Okay. But if you're a little more specific, and you want exact dates, you're going to start this on 1st of May. Okay, I'll put that 1st May here. 1st May 2022. Right? I'll select this day from here. So I'll say equal to this date. I'll tell you why I require this for a particular purpose. 1st day. Okay, then I will select these two activities. Right? Yeah. So before this, you should remember. Now I'm convert. These are in days. 1st May, 2nd May, and these are in weeks. So 3 weeks is actually 21 days. So that's why I made it 21 days here. So duration is in weeks, 21 days. So you can see it is into 21. Okay, it's 7 days. 7 days is 1 week. Okay. So you got the duration. So now what I do is I'll put a date over here. Select this. Same thing, insert, go to line, go to bar. Right, it's come. Okay, so click inside, right click. So now this is giving me only dates, I mean the activities and the duration. Now what I'll do is I'll right click and say format. No, select data, select data. Select data, and I will add one more this thing. The here I can call it duration. Duration. And here I will choose the column. This is the column of durations. Same way, we'll get it exactly in terms of days. Okay. So here I've got the dates. As you can see, again I'll do the same thing. I'll say I'll go here. No fill. That means I don't want that to be filled. Then I will reverse this order. Right click, format axis, categories in reverse order, and I've got this. Now here, the problem is it's starting a little awkwardly. So I want it to start on 1st of May. So you can see this chart. I hope so far it's understood. It's 1st of May. Okay, so I'm going to go start 1st of May. 1st of May. So I'll have to, no, I cannot remove this as it is. If I click on this, no, I cannot do any. I have to find out 1st of May corresponds to what day. So 1st May, I want to correct. So what I'll do is I will copy this here. But I don't want to change that. 1st of May, and I'll change this into a number. So Control 1, go to number and say OK. So 1st of May is 44682. Okay, 44682. So what I'll do is I'll come here, click here, right click, format axis. Yeah, here I will make minimum value is 44682. 680. Okay. Yeah. So that's gone. Yeah. There it is. And the last date, I don't want it to go more than 15th of March. So I'll say 15th March. Sorry, May. No, 15th February. 15th February 23. So this I will convert this into a number. Do Control 1. Convert that into a number. And I'll get the maximum value is 44975. 44975. So you click on this. Four, 975. So you got a nice chart with the dates. You can get these dates. I can make it a little smaller. We can expand it. Okay, you can get expanded. And supposing you change the date, if something happened, has changed to 1st of June. 1st of June. So you'll know you can control it very accurately if you have the dates. Automatically the shifts. All the dates will shift to June. Okay, it will control them. I didn't behind. Okay, yeah. So it will start from 1st of June. And you can identify the critical path. You can do it by the day. The same thing I've shown over here. You can finally get a critical path, which you can then identify. And then you can also assign who is going to do which job. So you can put your manpower here. These are the activities. And with the dates, you can control and you'll know whether you're running behind or whether the project is well within the schedule. So that's all I wanted to present in today's class on project scheduling, which is a very important technique. All projects need to be scheduled, and project scheduling techniques like Pert and CPM are the techniques that give you the timeline for any project report. So when you give a project report and when the client asks you for the timeline, this is what you're supposed to give. Finally, the Gantt chart will tell him whether what you have planned is in line with what he expects. And then he can allow you to, he can be tweaking this a little bit. He can be tweaking this a little bit. For that, there's another technique which is called crashing. So if somebody says, no, 41.42 days is too much, I want the project to complete at maybe 35 days, then there will be additional costs and the durations will be shrunk. And that shrinking process called crashing. So you'll have to again work out the durations and you'll find out the critical path and you'll know when you're going to complete the project. In such cases, using Excel will be very good. Once you've solved the problem, got the network diagram, Excel will help you to find out the critical path and the duration of the project. Hope you found the video useful. Thank you.